The next of my circuits I'm going to leave, but I'm going to look at the next circuit I'm going to look at is going to be my two-way lighting circuit here, which is 1 mil. It's 1 mil twin and earth. So we've got, I think it's way 2. So my 1 mil twin and earth. So first thing I'm going to do is my continuity of protective conductors, including main, equipotential and supplementary bonding, which I've done the supplementary and protective bonding. I'm now going to do continuity of protective conductors. For that I use the line cable and the CPC of my light circuit. Something we've got to look out for on the light circuit is that if there are any bulbs in place, or lamps as we call them in the trade, we're not going to go and try and carry out insulation resistance across the live conductors without those bulbs being taken out of circuit. So the way we've been doing it is using a Wago and my long nose pliers. Introduce that into a Wago there, that into a Wago there. Give it a little tug test. And now of course we can go to the end of line, which is where our breakout we could use, or we can go onto the ceiling rows as we wish. Probably advise you to use the ceiling rows, as that is the position most easily accessible for the CPC. The CPC in these plastic ones doesn't go through to the lamp holder, so even if we used a breakout box on this lamp holder, we wouldn't have the requisite connections. So I'm going to change over to probes again. Probes, a green probe and a red probe. Red probe, green probe. We're already zeroed for these test leads, and what we want is our mate, or left hand, our electrician's mate, to run between the two light switches, alternately switching them to the co-sequent, or the next pole. So what I mean is, I'm going to clamp my green cable onto the CPC, onto the switch line with my red. At the moment it's off, so I've got no reading. Switch on at, say, the kitchen, we've got 0 ohms. Switch off at the hallway, and we've got a high reading. Switch back on at the hall and switch back off the kitchen. So it's a series of alternate switches from one switch to the other, not just going to one position, switching it on and off, going to the other position, switching it on and off. We've got to do it in sequence. Now I've come up with a fault in this instance, in that when I put my probes onto the CPC and the switch line, what happens is, at the kitchen I get a reading, so I can turn it on at the kitchen. If I go through to the hall, switch that one, it doesn't turn off. I'm still with the same reading there. Go back to the kitchen, yes, it turns off then. So that is a question of the strappers being switched with the common. The common and the strapper, one strapper, is being muddled up in this instance. That's a typical symptom of that having happened. I've swapped the strapper back with the common now, so as to correct that fault. And let's see if everything's all right now. So switch on. We've got 0.37. Switch off at the other side. And it's 99.9 kilo ohms. Go back to the other switch, switch it back on. We've got 0.37 again, and back to the other switch. And that's off. So we've corrected that problem. So now we're going to look at the insulation resistance for that circuit, for which we will also need the neutral. We need to take the link out, and we're going to need the neutral as well. So I'm going to take the neutral out of its respective RCBO. Some of these screws are quite well rounded off, but at least it's tight. Right, so I'm going to switch to insulation resistance on my tester. I'm going to go between my line and my CPC, and I'm looking for a high, very high reading of 99.9 mega ohms if possible, or greater. I should have it on 500. If it's on 500 and not 250, you should see the maximum come out of 300 million ohms. And we'll test between the CPC and the neutral in the same manner, and then the two live conductors in the same manner, and that's going up in the same direction as well. So it's a question of replacing all that now. I'm going to put my line conductor into the line termination, which is marked with an L on the RCBO, and it's easy to muddle up because they both look the same. And carry out the tug test at the same time. I'm going to put my neutral in next. Okay, and my CPC in next. Now, these have both been quite easy to do. Now, I haven't been brilliant in carrying out my insulation resistance test on the light circuit. I got a little bit delayed because I had to swap one of the common leads with one of the strappers there. So we're just going to go and return to that now by taking out everything in the sequence that we had it. Carry out a new insulation resistance test between all three conductors. At this stage, I will come on to a little nicety on that front. Place the probes with our crocodile clips. There we go. going to put our multifunction tester onto 500 volts. First up, line conductor and CPC. We're going to put 500 volts between them and measure off 299 ohms. But at this point, our friend is going to go between the two switches, switching them alternately in order to expose all the strappers to that voltage. Now, CPC to the other line, the other live conductor, the neutral. At 299, and again all switch lines and strappers, and then the two live conductors together, for which you have to make sure that there is no lamp in the circuit, otherwise you're just going to put 500 volts across an accessory, being the tungsten or the LED driver, and you will possibly burn it, trash it. Okay, so that is the correct way of doing the insulation resistance there for those strappers.